we move ahead to the next module of stationary waves. In this module of stationary waves, we are going to learn about a very important and crucial experiment, that is the resonance tube experiment. Now this experiment is theoretically never expected in the board examination, but this experiment is very important as far as your board practicals are concerned, problem solving is concerned, and entrance numericals are concerned. So students, pay your best attention towards it. The principle of this experiment is that it works on the phenomenon of resonance and the formation of stationary waves. So it's a very important yet basic principle. Again, what do I need to determine in this case? I need to find out the velocity of the sound in the air at the room temperature. That means I need to determine what is V. So to move ahead about the experiment, let us understand the construction in detail. When I see this diagram of the construction, I can see that there is tuning fork which is present. There is a hollow tube, an air column which is present, and there is a water which is present. So can I say, to understand construction in detail, we need to go ahead point by point. The very first point says that it consists of a metal tube which is open at both the ends. Now one end of this metal tube is immersed in a tall jar which is filled with water. One end is closed by the surface of the water, and hence it behaves like a pipe which is closed at one end. So can I say that the length of the air column can be varied by raising or lowering this hollow tube? If I dip the hollow tube into the water, can I say the length of the air column will reduce? If I take it out, can I say the length of the air column will increase? And also, it consists of a tuning fork, which is the main source to produce longitudinal waves, or rather sound onto the vibration of air column. Moving ahead, how do we understand the working of the experiment? Now, we know that each tube has a frequency which depends on its length. We dip the tube completely and slowly make sure that it rises above. At the same time, we keep the tuning fork near the mouth of the tube. When we do that, we know that when the natural frequency of the air column will be equal to the frequency of the tuning fork, as I am taking it above the water level, can I say at one particular point the frequency of the air column will be equal to the frequency of the tuning fork, and that is the time, students, when one phenomenon will happen that we have studied, that is called as the resonance. And when the resonance takes place, it will make sure that it will emit a loud sound. So whenever there is an emission of loud sound, it means that it indicates that there is a resonance which is happening. Now a tuning fork is held near the mouth of the tube with its arm vibrating parallel to the axis of tube, and it has to be maintained in this particular position only. It need not be deviated because it might result in some error during the experiment. Also, the longitudinal waves, they travel inside the air column, they get reflected from the surface, and this reflection results in the formation of stationary waves. So we know that if this is the condition, or mathematical diagram will show me that there is a formation of resonance. So at first loud sound, at first resonance, I'll get the length of the vibrating column as lambda by 4. Now you must be wondering why it is lambda by 4, because as we all remember, the length of vibrating column for a closed pipe used to be lambda by 4, which is the distance between a node and an antinode. So when I move ahead, in the case of resonance, I know that length is given by lambda by 4. So can I say lambda is equal to 4 times L? But I know that with end correction, L will be equal to small l plus E, where we know that E is equal to 0.3D. So I'll remember that while solving these problems. Again, moving ahead, I know that lambda will be equal to 4 times capital L. Now capital L is replaced by small l plus E. So can I say V is equal to n lambda, and I know n will be the frequency, and lambda will be 4 times L plus E. So the velocity of sound in air will be 4 multiplied by n in bracket L plus E. From the experiment, we can get L, we can get E. From the experiment, we can also get the N, that is the frequency of the tuning fork only, because they both are in resonance. So all the data is known to me. I can substitute the values and get the value of V. So with the help of this module, we determine the velocity of the sound in air with the help of an experiment called as resonance tube experiment. Thank you.